And I think what I'm going to focus on is the server-side logic concerning where it picks, like, data transfer integrity, to ensure that whenever we're transferring data, whenever we send it specifically, that we're ensuring that it gets sent. We're not just assuming that it gets sent. And also, the second thing is whenever the server is sending data and then there's a disconnect of one of the clients, we want to make sure that we pick back up where we left off as far as where the server-side loop was in, because we do have these exceptions in place. And it's not like you can... It's not like you can catch an exception and then go right back to where you were. You know what I mean? You know, it just doesn't work like that. So we have to figure something out for that. I guess this is the easier of the two things, though. The second thing requires like brainstorming and me learning and creating more of an outline and all that. And it's going to take a little bit of time, unfortunately. But yeah, I did realize that we weren't completely finished with, you know, data exchange as far as like integrity, like basically in the case of disconnects. That, and I've been dealing with that all over the code base to improve the data transfer integrity and security and all that stuff for disconnects. So anyway, self-sent data storage is going to be a list to store our sent data in the case we need to resend if the client disconnects, etc. So how are we going to populate the sent storage? Well, I'm not going to populate the sent storage until we get to, I suppose, the main while loop, and we're going to, you know what, I can just put it in. It's fine. I kind of like it like that. Anyway, so whenever we send. So we're gonna go down here. Not for if ready. We're not worried about for if ready. Okay, so that's the receive section. You know what? Actually, I think I do like this better. Just like putting this right here will help me to... I don't know about that, actually. I'm wishy-washy, Anna. Yeah, whatever. We'll leave it like this. Okay, so at the start of the send section, that's where we want to jump in. And whenever we go to send data, after we have sent it, this is, so we're gonna put in something that says ensure sent data storage is populated. for both connections, and also how long are we gonna want to store? Well, I guess store until verify received. So once we verify it's been received, then we don't need to store it anymore. After the send. So after the send, we ensure that the send data storage is populated for both connections. So that would mean we might need to actually make sent data storage be a dictionary instead of a list to so whenever we store the sent data, we need to this is a little bit complicated when you're dealing with multiple threads and multiple connections. So whenever we have sent data, okay, so let's say we send it from client 1's thread on the server side. If we send it, let's say it's client 1's thread, we send to client 1 the data, and then we also send to client 2 the data, because that's how it works. We send to other client as well from server side. But if we only have, like, if I were to only have one sent storage dictionary, would that work? Like, I don't think it would work, because since we have multiple threads, that would be a race condition, first of all, if both of the threads try to modify the dictionary. But another thing would be if we're sending data from a particular threaded client, then I feel like we should I don't know if both threads would send, like, if yeah, we would have to divide it per thread. I'm trying to think how to word this. If we sent something from client 1 thread to the other client, the current client and the other client, and then let's say the other client disconnected or whatever, and then whenever they reconnected, it's like, could we just let the other thread send them that data? But because, like, technically they could have access to that, but how would that be accessed? That would be accessed through the storage. So that would be a shared object between the two threads, which would result in a race condition. So I think ultimately we would have to have two storage. So we need to create two separate storage, and we're gonna make these into dictionaries. So it's gonna be data storage dict. Data storage dict. Create two separate cent data storage dicts. One for each client. And we'll put dict key equals. We'll make the. So we could make the key be like a timestamp associated with each send. Oh, and I just realized right here we would need to check the length of the change attribute list again, because we very well may have removed. So that's technically, so we need to check it again. Yeah, so let's do this again. We'll put checks again after third check in case values removed resulted in len equals 0. So in this case, we want to send data. Okay. Yeah, because we don't want to send any empty, it's just like pointless to do that. So we could have, would be first timestamp would be the key. Like the first timestamp from change attribute list. Yeah, so we'd have the dict key would equal the first timestamp from current client change attribute list. Okay, dict key equals first times current client, and then the dict value will be the entire current client change attribute list. Yeah, that'll work. So we'll create the first timestamp. We'll say first timestamp equals we'll say current client change attribute list 0 0. So the first entry in the change attribute list is going to be a tuple, and the first element in the tuple is going to be the timestamp. So we're going to do current client change attribute list add 0 index add 0 index, and then we're going to say current client dot, or not current client, rather this is well, actually, you know what? Well, no, this would want something we would want to be the servers. So this would be self dot like client one assign. We could have a client attribute that is assigned to like the server's attribute, but that's kind of weird. I would rather just have a server attribute, which would be like client one sent data storage dictionary. Yeah, so we'll do this. If if current client ID is equal to 1, then we'll say sent data storage dict equals, and then else sent data storage dict equals self.cl2. Okay. And then server adders called this. First time step equals current client change attribute list. If current client ID is equal to 1, send data storage dict else. Okay, and then well, then we want to append the key value pair to the dictionary. So then we would say sent data storage dict at the key being the first timestamp, because that's going to be a unique identifier, and then equals the current client's change attribute list. Change attribute list. All right. Okay. Creates the variable to point to proper storage, sent data, storage data. Can't type at all. And then this is going to be key equals first timestamp, val equals current client change attribute list. And then I'll just put this in its own little div. So we'll go up here and we'll say below section created 5/19/24. Gets the first timestamp from the change attribute list. Gets the first timestamp from the change attribute list. Assigns proper var for assigns var ref for proper sent data storage date. And then creates key value var. Stores the sent data to until client verifies it has received. In case of DC, etc. In the case we need to resend data. Alright. Okay. So let's go ahead and create those two storage dictionaries. So we're gonna have client 1, and this is gonna be a dict. So this is gonna be changed. Dict, and then key equals first timestamp from changed attribute list. Val equals changed attribute list. Alright, and now we're gonna have one for client 2. There we go. Alright. And we're gonna assign let's see. Okay. Well, we actually, no, we could do that, yeah. Yeah, we could assign a, yeah, we could assign this up here. Sent data storage dict would be equal to self.c1 sent. And then if it's number 2, we would do it like this. And this would be C2. Almost forgot to change that, which is actually important. So this we wouldn't need to assign here. Okay. So now we need to add in logic, which will add logic elsewhere, which will depopulate the sent data storage upon reception of receive verification. Okay, so where would that go exactly? To depopulate the... well, it would have to go in the receive section, wouldn't it? Yeah, that makes sense. Okay. Yeah. No, 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 but I'm gonna go see the kids in a little bit. Appreciate it. Um, Alright, so let's go back up here. And I guess then we could check to see if it's a tuple. We say received data is if type of received data is equal to tuple in this data is, or received data is change attribute with this, then we'll do this part. I just realized something, like when we send, just realize that whenever we send to other clients, we send to the other client, we are not going to receive oh, okay, hold on. On the server side, when we send out, when we send back from the client, it's like, wait, which thread would handle that client's receive? Well, yeah, no, that's only through the that's through the each separate socket. Oh man, it's like a severe brain exercise for me when I think about this sort of stuff with the multiple clients. If server thread 1 client sends to client 1, whenever client 1 sends back to whenever server thread 1 sends to client 1 but also sends to client 2 in the form of other client, whenever client 2 sends back the verification that they received the data, that would come from the other client. But like, if it is sent through that socket, then how does like the proper thread receive the verification? Well, because previously we never sent data back. Like, we never. Well, okay. I've confused myself. It is a little bit confusing, but I'm making it confusing. So I'm just like, whenever I'm confused now, man. Whenever we send data from the client side, don't we receive sometimes in terms of other client? Because if I'm just trying to think of like an instance where we would receive, I'm just like, wait a second, we wouldn't ever receive the other client's data from the server side, right? Because each threaded client on the server side is attached to receive from only one of the connections that it's associated with, either one or two. If it's client one, it's connected to connection one. If it's client two, it's connected to connection two. So that means there's this socket, this is connection one on the server side, and then there's connection two. If each thread is associated with each socket, then that would mean that on the client side there's a one-to-one attachment, which means whenever they send data back from client one, it's going to go through that client one socket. If it's client two, it's going to go through that client two socket. Which that would mean that we would never receive in terms of the other client from the we are not going to receive in terms of other client, since each threaded client is attached to, and we'll just like make this a multi-line. Since each threaded client is attached to an associated socket for receiving, Since each threaded client is attached to an associated socket for receiving. Yeah. Since each threaded client is attached to an associated socket for receiving. And we'll put this means that the verification would happen, receive would occur from the other client, not the one who actually sent the data. Other clients' perspective. Okay, since each threaded client is attached to an associated socket for receiving, this means that the verification received would occur from the other client perspective. This means we need logic on each client receive to determine which sent data storage dict to refer to when depopulating after receive verification. Yeah. Yeah, so that's actually really important. So if type of received data is equal to a tuple, why did this get indented? I don't think that needs to be indented. And then we'll say else, or else, and this is going to be received data is received verification. Then in this case, we need to determine which determine which sent data storage dict to modify in case of send from other client or receive verification. Okay, so we're gonna go ahead and stop here, and I'll just put we're gonna put the debugging, game testing, and I'll just put these over here. Oops. Copy it all the way. debug game test. Discard bug should go in that one. Okay, now let's put the current issue is going to be finish by receive verification. 5.19.24. Finish implementing logic, etc. for receive verification system. Stop, and then we're going to put 5.19.24 stops at line number 226 and 5.19 at 11:57. Okay. And I'll put this here. Alright, now let's go to devlog, and we'll put this in our devlog that we're going to stop at 12:05. This is 1 hour into 12 to 11:58. We began implementing receive verification system ons in made first pass of most required logic, data structures, etc. And then from 11:59 to 12, we're going to stage commit and push our changes. Alright, let's go ahead and do that. So let's do git branch to see what branch we're on, and we are on secondary. So now let's go to the root project directory, which we are in. So we'll do git add .add everything. Now we're going to do git commit m, and we're going to copy this message and paste that in. There we go. 90 files changed, 260 insertions, 188 deletions. Now we're going to do git push secondary Canasta. Oh, duh. I had that backwards. Canasta secondary. Now everything is pushed successfully, so we can close this. We're gonna open up our programming folder, go into projects. We're gonna go into Canasta. We're gonna copy this. We're gonna back out. We're gonna go to the backup. We're gonna delete the old backup. Hit OK. There. We're going to paste in the new backup, and we're going to verify first off that we do have the proper data in our copy, which it looks like that's correct. Today is the 19th. So now we can back out and rename our backup folder to today's date. And there we go. Now we have a local and remote backup made. And that's it. I'll see you guys next time. Have a good one.